Hello everyone and welcome to this video. I'm the developer of FreeDi and today we'll be walking through a complete installation process. Together we'll be installing FreeDi on a stock QIDI printer and do the first steps. If you don't know already, FreeDi is a powerful software package to improve your printing experience. It includes a custom display firmware and software for seamless communication with your printer. It is all based on pure armbian and Klipper and all untouched software. To the date, all X3 series printers being supported. If you want to support this project, you have different options like sharing it or share your ideas, and you can of course also buy me a coffee or leave a star here on GitHub, which helps to get more popular. Now let's first check if FreeDi is the right fit for you. It's not for you if you're completely satisfied with the stock system. And also if you're facing any hardware issues. It's a software solution and it cannot solve that. But if you like to have an open and up-to-date system for installing the latest software, or you simply want to get rid of the stock software bugs, FreeDi might actually be something you should look into. In this video I won't go into every detail, but before we start I want to give a short disclaimer. FreeDi is a complete hobby project and using my firmware is at your own risk. However, if you're facing any issues, feel free to open an issue report here on GitHub and I try to solve that for you and work around. Before we get started, I want to go to the top bar and show you the wiki page so you can easily navigate there from any page. Now, let's go down again and start with the installation guide. On the right side of the wiki, you will find a navigation bar to navigate through all the menus, and I invite you to do the whole installation guide. Now, FreeDi already has a wide range of users, going from hackers and tinkerers to someone who has bought a QIDI printer as their first printer. And there are different ways how to install FreeDi. And if you already have an open Armbian system, you can go with the advanced way. But we'll do the stock system and the beginner's guide first. So let's start with the requirements. There are some bits and pieces that you need to have to get FreeDi on your printer. And the first thing is you need to have a EMMC flash reader. And you might see that there's an option for a USB flash drive, but currently there are being issues, so don't use that. The second important thing is a wired connection. There is no other option for that right now. I'm trying to solve that. But if you haven't done it for now, just plug in an Ethernet cable and you're good to go. And as a last hardware requirement, you need a microSD card. I know it says optional right now, but it's a mistake and I'll fix that. When it comes to software, you need an SSH terminal, an image writing tool, and an SFTP client. I have links so you find it more easy for you. And lastly, just as an information data, you need the username MKS and the password MakerBase. Just note that down somewhere so you don't forget it. So the next chapter is called Why Creating a Backup is Important. And I know that you know and everybody knows that creating a backup is always a good choice. But the X3 series of QIDI came with different hardware revisions and also different components. And so you might have a unique mix of components. So please do a complete backup of your system so you actually might be able to set the config right for your system. We will do this right now as a basic backup in Fluid. And on the page, I have screenshots how to do that, but for simplicity, I just head over to Fluid. You might be familiar with this web interface already. You see all the things that you're used to see. On the print job section, you can see all your G-codes. Some of them have thumbnails, some of them don't. I don't know why I always had problems with thumbnails on the stock system. And down here you can see the Klipper version 0.10 on the MCU and the Toolhead. This is not so important because we will flash it, but I just want to give you an overview before we start. Alright, so let's go ahead and start making the backup. You can see here on the screenshot how to do it. Go over to your Mainsail config page and right click on each file and download it somewhere where you can find it later on. I will fast forward this process because there's nothing special here. Just download every file and boom, there you have it. If you have already modified your printer and installed Mainsail on it, there's also a section how to do a config backup on Mainsail. And always a good idea also is a full image backup with reading your EMMC by an EMMC card reader and do a full image backup. This is always a good idea, but we won't cover this in this video tutorial here. If you are one of those advanced users I was talking about and you have already installed an open armbian system on your printer, please go ahead and choose way A for advanced and you'll find a section how to get FreeDi going on your system. I won't go into details because this tutorial here is intended to be a beginner's guide, but basically you have to rename some of your components to copy paste something and then in the end start a bash script. And if you are sitting there and don't even understand a word I was talking about, no problem at all, you're at the right place. Let's start way B, the beginner installation guide. And don't get me wrong by the word beginner, it's just a word to hook everyone who is new to 3D printing and the whole Klipper universe to easily find the matching installation guide. So the next step we need to do is to install a fresh and clean operating system on your printer, which may sound difficult at first, but it's actually pretty simple. I prepared some image files for you and provide them always in the release section. Just head over and you want to find a major release where at the very bottom you can find some assets. So here you can see the assets being loading and then you will find different printers that are provided and download the image file matching for your printer. In this case, I want to download the one for the X-Max3 and I'm going to download this right now. So now as the file is being transferred to my computer, I'm opening Win32 Disk Imager because we will need this soon. And as you cannot flash the archive directly, you have to unpack it first and this takes some time. I will fast forward to save some time. And then we can flash it. But wait, we don't have the EMMC card, right? So go to your 3D printer and shut it off. And I would also recommend to unplug the power cord. Now we need to have access to your main board, so unscrew the back cover and open it up. The EMMC module being secured by 2 screws. So to be able to pull it off, we need to unscrew them first, and with a little bit of wiggle, we can pull it off. So this is the EMMC card, and I have an EMMC to SD card adapter. This is how these should be connected. And I have a USB to SD card reader, and just plug it in. Easy as that. So take the USB reader and plug it into your computer. Don't worry, if you open your computer and the flash drive, you will see some warnings and pop-ups that you cannot access this drive and it needs to be formatted. You don't have to worry about that. The only thing that we need to know is the letter of this drive. In my case, it's D. Just note this down somewhere or remember it. It's very important because we don't want to write the image file onto a different drive. So D is selected and we go over to the place where our image was unpacked, select it and open it up. The first thing here is the read button and the second is write. We want to write the image file to the EMMC and I'm going to click that now. You will be asked if you really want to flash that image file to the EMMC drive. Hit yes if you double check that, and wait until the writing is completed. A little window will pop up saying that the writing was successful, and you can hit OK and shut down Win32 Disk Imager. Detach the eMMC reader from your computer and place the eMMC back onto your mainboard. Don't forget to secure it with the 2 screws and close the back cover. This is a crucial part because it will cool the mainboard, and this is important for the boot up. You will see the QIDI tag boot up screen, and as soon as the operating system boots up, it will detect the screen and flash the new firmware on your screen. When it's finished, it will check the data and report update successed. I know it's a typo, but it's in the bootloader, I cannot change that. And then you'll be forwarded from my software to the Klipper reports error screen. Don't worry, this is completely normal. We have not configured Klipper to your unique hardware yet, and we're doing this right now in the section creating the perfect match with your hardware. So the next step we need to do is open our browser and access the printer with entering the IP address. Don't use the port 10088, just the IP address, and you will be forwarded to Mainsail, the new interface. We have now successfully installed the new operating system and can see the new Mainsail web interface. If you go to the Machine tab, you can see the Update Manager, where we can later update our softwares. And on the top right side, you still see the Klipper reports error message. When everything is set up correctly, we will see a system loads window instead of the error message that we saw. So the next step is we need to configure Klipper to match your specific hardware. Remember the backup that you made previously? This now is very important. Head over to Mainsail and go to the Machines tab and open the printer config. The included printer config matches already most of the parts, but take your time here to compare your old printer config with my provided one and to see if there are any changes. Sometimes it's a little bit of a surprise what kind of hardware-software combination the guys out there had. So the first thing would be matching the printer model. Make sure it matches exactly the string in the comment. For me, it matches because I have an X-Max3. And to make it easier, I have also included a special kind of char set, a string, which is hashtag exclamation mark hashtag. Just use that and hit Control F, or I don't know what's on the Mac, and search for this specific string and find the most common section that needs to be adjusted. So on my printer, I know that I don't need the MCU fan. This is not controllable on this motherboard. It's an older version, so I can delete it. And also I don't have the hot end fan 2, and I will also delete it as the comment says. So I hit next and I will see the run currents. And for this parameter, I'm not 100% sure. So I will head over to my old printer config and compare these options with the ones that I had. And the first thing is the run current of the extruder motor, and it's 0.714. The X motor is 1.07, as well as the Y motor. And here is something else, also on the X and the Y. I don't know why it's there. And the Z is 0.95. And if you haven't noticed by now, the old printer config is a lot messier than the one that I provided. So I hope you find it handy that it's clean and you can organize it better and see where it goes. I also have a post install and config section. And there are some things that you might head over for improving the thumbnail quality and the most common things that you might miss or needs to be changed. As I said, I have already noted it down in the printer config, but if you have missed it or deleted it, you can find the most common parts there. So, okay, we have now configured our printer config and we hit save and restart. While Klipper is starting, we go back to our installation guide and we have to choose one of the 3 paths. Number 1 is for the advanced guys who has already installed Klipper on their subsystems, which is not the case for us, so I will collapse it and choose number 2, because this is our case. We are not on the latest Klipper and want to have it on the easy way. So I pre-compiled some Klipper files for your subsystems, and we have to flash the Toolhead now and also the MCU on your mainboard. I'm opening up the SFTP client because we need to download a specific file and upload it to your printer. It's located in home MKS3D or home user 3D, whatever your user is right now. I'm planning to do this in the future for you, but right now it's not included yet. So head over to the mainboard and Toolhead firmware section. This is a folder in my GitHub repository. And then you'll find the latest Klipper version. Please don't right-click on these links and save as, but click on these links and download the files as raw file. This is very important, otherwise it will fail because these files will be corrupted. So just do as I do, download raw file, save it somewhere where you can find it, and you're ready to go. Find the Toolhead firmware on your computer and upload it to the right location on your printer. And then you can close or minimize the SFTP client. So let's now flash the Mainboard MCU. For this, you need a microSD card and it must be formatted as FAT32 and not larger than 32 gigabytes. I'm planning to make this step a little bit easier for you, but right now the microSD card way is the most robust and easiest way for you all. Later I will do it in software just to flash it via terminal. Grab the X_4 bin file and put it on your microSD card, and now switch your printer off and also unplug the cable and put the microSD card into the microSD slot of your mainboard. Now turn on your printer again and the flash process will automatically start. Just wait like 10 seconds or so and then you can shut your printer off again. And that's it. Pretty easy, right? You can remove the SD card, and as a pro tip, make sure to not drop it down. You can verify if flashing was successful if the name has changed to CUR at the end. So now we want to install the latest Klipper firmware onto your toolhead, and this is also the last step that we have to do to finish the installation process. To do so, we need the unique ID of your toolhead, and for this, just take this line here and copy it, and then open your SSH client and log in. Then just paste this line and see the unique ID that you get, and copy it because we will need that, and insert it to your printer config. I will now go to Mainsail again. You may need to scroll down a little bit to find the right MCU MKS_THR section, and then you can paste your unique ID into it. For this video, I'll do it like so. This makes it easy to compare those two unique IDs and see that they are different. But I like to have a clean printer config, so I'll delete that line and hit save and restart. So this is great. We have now completed the whole Klipper configuration. Let's now flash your toolhead. For this, we need to remove the back cover and to firstly find the boot and to reset button. Here's an example picture of where they could be located, but first go to your machine and remove those 4 screws on the back side. Then pull off the back cover and you'll see the daughter board. We need to bring the toolhead into the boot mode, and for this we have to press and hold the boot button, then shortly press the reset button and then release the boot button. It may not work on your first try, but you can repeat the video to see how I did it, and I hope it helps you to bring the toolhead into the boot mode. Let's now check if the toolhead is in boot mode. I entered the ls-usb command, and intentionally it is not in boot mode. I did it differently than in this video that I showed before, just to show you that if you see this one and compare it with the left side, this is not in boot mode. So if you see the open Moco, please go back and repeat the process to bring it into the boot mode. And if you do it like this and you see a Raspberry Pi RP2 boot, then you're good to go and you can proceed. The next step is to find the partition of your toolhead, and for this we enter lsblk to the command line, and we want to search for a partition that is exactly 128 megabytes. In my case, it's called SDB1. Just make sure that you have the right name and note it down somewhere. We will now flash the Klipper firmware by copying this line, but make sure that the name matches exactly the one that you found earlier. In my case, is SDB1. Enter the password makerbase, and that's it. It's not a must, but I highly recommend to shut the system down and off by using the switch. This is because the toolhead sometimes gets stuck in a boot mode state, and to overcome this problem, you can simply power cycle it and it will just boot up fine. When your system is ready again, go and open Mainsail and hit the refresh button. You should now see a screen like this, which means that everything is alright. So congratulations, you're done. You have now a completely open printer with the latest software. You can go ahead and play around, install plugins, do with your printer whatever you'd like to. But if you don't see the screen for whatever reason, or if you got stuck on a different part during the installation process, don't worry. Just go to my GitHub repository and open a new ticket in the issues section, and we'll try to solve and help you out. Please don't go on a different route than I described here in my video. Don't do way 3, which is really only for advanced users who are familiar with Klipper and who wants to compile Klipper on their own. Alright, so the printer is now ready and you can use it however you want to. I invite you to see the first step section, which is still under construction, to see some recommended but also some mandatory steps. For example, the Z-Offset calibration and the input shaping are some steps that has to be performed, and it was also initially done with your stock system. But before we do that, I want to show you the whole menu and walk you through all the submenus, and of course don't forget to place the cover back onto your toolhead. So this is the home screen, which contains the most common parts. You can simply change the nozzle temperature by clicking the icon on the home screen and type in your preferred temperature. You can easily see the current and the target temperature, and if you want, you can also use this menu here to change the temperature and hit OK. It's the same for the bed and the chamber, so I won't show that. But if you want to switch the light on and off, just click the bulb icon and it's done. For the fans, the most handy part being the right side with some presets, I think. But if you prefer, you can also use the slider. Just notice that it only will refresh the part cooling fan in this case if you release it, not while dragging. On the bottom you'll find some handy presets. If you, for example, hit the little snow icon, it will shut it off, or you can preset it to PLA, ABS, PTG and TPU. Let's go to the Move menu. It's hard to see, but the X, Y and Z buttons being gray right now because the X is being not homed yet. If I hit this button, X and Y only will home. And as soon as those X's being homed, it enables the buttons to be used, which is right now for Y. Change to your desired length and then you'll be able to move to the direction, and on the bottom you'll see the coordinates. I think this should be sufficient. Let's go to the file manager and see and compare the differences to the stock firmware. Yes, we now have mini thumbnails. And I hope you also noticed how fast they are being generated. If you haven't, rewind and enjoy the show again. Now, I want to highlight the improved thumbnail quality. The second file is an old one from the stock system, while the first one was generated with the new settings. Let's compare it with the stock system. Notice how you can see the pictures being built up. If I open the same file on FreeDi, the thumbnail is almost instant there. But of course it doesn't change the quality. I think this looks a lot better. You can have it if you follow my recommendation how to set your slicer. Let's click on that gear symbol to open the extruder menu. This menu is meant to extrude or retract filament and also to unload or to load the filament. The temperature settings is just like I said in the main screen, and you can extrude as soon as the temperature reaches at least 180 degrees Celsius. Again, it's hard to see in this video, but currently the move button's being gray. And if you wait a little bit and see the point where the temperature reaches 180 degrees, you will see that the buttons become blue, which is now. Nothing too special here. You can also set a different temperature. I will rise it again a little bit to reach 230 degrees because I actually want to extrude something. As in the Move menu, you can select the length, and in this case I want to extrude 20 millimeters of filament, and as soon as I hit down it will extrude and also start a little animation. On the top you will find different tabs, and I'm going to the Advanced menu now, and there you can use the filament sensor. It's now being activated, and as soon as I hit it, it's being deactivated, and it also changes the icon, and I'm going to change it back again so it's activated. There are some preset languages which you can choose. I stay to English. On the stock system, I was always wondering why there's no option to safely shut the system down. If you want to do it now, you can do it in this menu. Additionally, you can restart Klipper, the firmware, or the whole system. Let's go to the next page. Here you can do a Z-Offset calibration, input shaping or bed meshing directly from the screen, or simply change the settings, which we will do right now. Use the slider to adjust the screen brightness according to your preference. And if you want to, you can also enable or disable dim screening and also change the dim brightness. It will change the screen brightness because it's a global setting, but as soon as you release it, it will jump back to where it was. And of course, you can change the delay. On the next page, you can enable and disable the screensaver and also change the delay time, but we won't do this now. And on the last page, you can change the acoustic feedback, set it to off, and you won't hear anything. And if you go back and turn it on, You will hear sound with every touch that you do. I don't like it, so I will disable it. Please don't forget to change the printer model according to the one that you have and hit the Save button. If you go to the next tab, you will open the network menu. Here you can see that we have an Ethernet connection, but no Wi-Fi connection. And if you want to change this, just click one on the list and it will open the password insert. Just type in what you like, and if you want to see what you just typed in, you can hit this button. And if you press OK, you will connect. But right now we won't do that. If you cannot see any Wi-Fi in the list, it's because your Wi-Fi module is not activated. The reason for this is that QIDI ship different Wi-Fi modules and I can only enable one by default. It's not a problem, you simply have to activate yours or install the driver, and you find a section in the wiki how to do that. Last but not least is the emergency button, which is always in the same location and is visible on every menu as long as the software has connection to Klipper. So if you hit this, you will need to restart the firmware, as the state says. Wait a little bit until the software connects to Klipper and you will be forwarded to the main page. Let's do some of the first step together now, and we start by calibrating the Z-Offset. You can directly do this from your screen. Just go to the right menu and hit the Z-Offset button. Wait until the printer finished its movements and grab the original calibration card if you like to. You can also use a regular sheet of paper and adjust the settings so that you just feel a little bit of friction there. This is a good start, and we hit accept and we're done with the rough Z-offset calibration. You can verify that the new offset is successfully saved if you find this section at the very bottom of your printer config. And that's it. The next step is to do input shaping. This can also be done directly from the display by hitting the input shaping button. It will home and then start to make some weird noises. Just give it some time to finish the measurement. You will not get any notification on the screen, but you can verify that everything was successful if you find this section right at the bottom of your printer config. Another step I do recommend is PID tuning the nozzle and the bed, and because these steps are pretty similar, we do both at the same time. So for the nozzle, just copy this line here in way number 1. This will always work for you. Go to your mainsail and you can find a little window on the dashboard for the console. Just enter those commands and hit OK. Or you can do the same thing in the console menu. I won't do this right now because I'm planning to integrate this as a macro in my future releases. And I take this as an opportunity to show you how you can add macros to your printer and how they be configured. So this is the macro that we want to have. And I want to include this to look like this. First, let's check if we have this macro already. Go to the dashboard and scroll all the way down and see if you find a section like this. This is not the case for me, so I do copy this and go back to my printer and go to the machine settings to open the macros. I'm scrolling all the way down and find the right location where I want it to be. And for me, it suits well for the tuning macros. So right now you can see this section is not inserted yet. So I'll do this now. If you want to make these changes take effect, you can hit the save and restart button. But as I mentioned earlier, this is the same process also for the bed. And I will just combine it right now to save some time. Just click on the PID tune for the bed. Scroll down, it's almost the same. just a few parameters being different. Copy also the macro for this one. Head over to your printer config and insert this section. If you like to, you can delete these additional spaces that I have right here. I don't like that. And hit save and restart. Klipper's now restarting and the macro is being installed. But if you go to the dashboard right now and scroll down, you still cannot see them, right? To make it visible, go to the macro settings and add a new group. I will name this group calibration. If you like to, you can change the color. And I only want this group to be visible when the printer is idle, but not when it's paused or when it's printing. So I just check this out so they are not activated. And then I scroll down and search for all the calibration macros down in the list. Just add them. And if you are ready, you can close this window by two different ways. You can either click on the X icon on the top or just close the group first and then close the whole settings interface. Okay, if we scroll down now, we can see the calibration window here. This is nice, but I would like to have it a little bit higher, so I just drag it to the place I want it. And then I have it. This looks better for me, but in this case, I want to show you the temperature rising and going up and down. So for now, I will just drag it a little bit higher so I can click this button while seeing the calibration. Let's start the nozzle PID tune. You will see that the nozzle temperature changes and the printer is doing some measurements here. Just wait until this process is finished, and then you can see an output in the console saying hit save config for these parameters to take effect. We will do this now to save it. And after a restart, we can check if the new settings being now saved in our printer config. To do so, just open it, scroll all the way down, and you'll see an extruder section with the new settings. Okay, everything was alright, so let's get back to the dashboard and start the bed PID tune. It's the same procedure. You will see that the bed will rise, but it definitely will take a longer time because the bed is a little bit slower on heating and cooling down. As earlier with the nozzle, you will see a notification in the console saying hit save config to make these changes take effect, which will then save this also into the auto-generated section of your printer config. So get to the machine tab, scroll all the way down on your printer config, and there you have the heater bed section. That's it. If you want to have these nice looking thumbnails, just go to the wiki and open the post install and config section. You'll find configurations for different hardware settings, but also how to improve the thumbnail quality. You'll find a guide how to do this in Orca Slicer and also for the QIDI Slicer, and I'll do this now for the Orca Slicer. So start Orca and check if it has connection to your printer. It might actually not because the port has changed, so be sure to leave the port out, just your IP address, test that everything is alright. The next step is to change the way how Orca Slicer integrates the thumbnails to your G-code, and you can do this by copy this line and paste it into the G-code thumbnails section. Don't forget to save these settings, hit OK, and that's it. I will now add some primitives onto the print bed and slice the bed and send it to the printer. Just name it like shapes new and upload it. And on Mainsail you can now find it in the G-code files section. And here you also see the thumbnails and the G-codes that you might have seen previously in this video. If you installed the FreeDi image on a larger EMMC drive, you might have noticed that you cannot use the whole flash drive. You can see this by the free disk area here in the Machines tab. Currently I have already expanded the file system, but if you want to do that, just go ahead and use this line, copy it and insert it to your SSH terminal and hit enter. I won't do this now because I have already done this, and then you have to reboot the system. You can do this by rebooting like this or by entering it into the terminal. When the system reboots, please be patient and give it some time because it needs to do some changes to actually resize the file system. If QIDI shipped your printer with a different Wi-Fi module, I'll show you how you can activate this. This process might be a little overwhelming and complex because you have to search the module that you have attached, plus installing the driver and activate it. And to make it easier for you guys, I have prepared an installation script, which you can simply copy this line and then open your favorite SSH terminal and enter this line. Just paste it there and hit enter. And you'll be asked if you have a stock mainboard. So if you didn't replace it with some fancy stuff or something, just hit Y for yes, and then the installation script will automatically do everything for you. If you get any error messages and Wi-Fi is not working for you after a reboot, please do a screenshot of these error messages and open a new bug report on GitHub. It might be that QIDI shipped your printer with another Wi-Fi module, which is currently unknown for me. So I want to make it working for you and also to support it in my firmware. If Wi-Fi is now working for you, simply connect to your preferred Wi-Fi through the network menu. Okay, so here's the truth. FreeDi is not perfect, and unfortunately some improvements or bugs cannot be fixed with an update. For example, I received a false positive feedback that the M191 macro for the chamber heater is working fine. But after I released the latest image, I realized it wasn't actually included, and I'm really sorry about this. Now, let's use this as an opportunity to point out where you can always find the latest configuration. To do so, go to my GitHub repository and find your printer model in the config section. Open this subfolder and you will find the printer config, the Moonraker config, and the macros. In this case, we want to search the M191 macro, and it should be somewhere at the temperature macros, a little bit more to the bottom, and there we have it. So I'm copying this macro right now and going to the macro config, and I want to place it on the same area. So I scroll down to the temperature macros a little bit more and I insert it here. To finish this, I hit save and restart and wait for Klipper to be rebooted. And that's it. Now let's do a fun part and do a side-by-side comparison between the stock printer on the left side and the same printer with the FreeDi firmware on the right side. It's exactly the same G-code file, I just renamed it on the left side with 00 at the beginning because of the ordering at the screen, so I can find it more easily. This is just one aspect of the improvements, but I think it's really relevant for all of you how much faster every print will start now with FreeDi. So besides the fact that the printer is now up to date and for my taste, the user interface on the display is looking better, it gives a benefit for everyone even if you don't modify it or do some customizations now. So you can see and compare the time for the meshing only or the meshing and nozzle heat up for yourself and decide if this benefit is for you. Of course, I cut out the bed heating because this is the most time. So that's it, and thank you all for watching this video. And I also want to thank everyone who supported me. Bye.